Okay, so now let's try some logarithmic equations. Our logarithmic equations are the type of equations that we can solve by using one of the inverse properties or perhaps the one-to-one property, depending on how the equation is written. Here's an example of one that is really one of the simple types of equations, even though we don't say it as such. The natural log of 2x equals 2.4. Well, we're going to take advantage of the property here that tells us that if we have a base a and we raise it to a logarithm base a of x, we get x. In other words, the inverse property allows us to isolate x by picking another function that will undo that logarithm. So if I have the natural logarithm of 2x equals 2.4, then what I'm going to do is I'm going to exponentiate on both sides with the base of this logarithm, which is e. So I'm going to have e raised to the natural log of the quantity 2x, and that will be equal to e to the power 2.4. Well, on the left-hand side, e to the natural log of 2x by our property above just comes out to be 2x. And we've got e to the 2.4th power. To get x by itself, multiply both sides by 1/2, and we would say that x is equal to 1/2 of that quantity e to the 2.4. And we can approximate what that would be using a calculator, but in this case, we're just going to leave it right here. It's 1/2 e to the 2.4 as our exact value solution. All right, let's take a look at negative 2 plus 2 log of 3x equals 7. Now, there's a little bit more to this one. So because we have a lot of different terms attached to this logarithm, before we deal with anything, we need to somehow isolate the logarithm. So in order to take advantage of our rule over here on the left, we need to isolate the logarithm of 3x. Now, this is going to be a bit of algebra. First thing, of course, we would want to take our negative 2, which is added to 2 log of 3x, and move that to the other side by addition. So if we do that, if we add 2 to both sides, we get 2 times the logarithm of 3x, and set that equal to 9. And of course, that will be equal to 2 plus 7, which is 9. All right, so now another step right here. We need to get the logarithm all by itself. That 2 will never fly. So what we have to do is we have to divide both sides by 2. And now we're going to get our logarithm of the quantity 3x equals to the fraction 9/2. All right, now we can use our base. Now, the one thing we should note is, well, what is the base of this logarithm? Because it's not written. Well, that's right, it has to be 10, right? Because that's called a common logarithm. When we don't see the base written next to the logarithm, that base has to be 10. All right, so this is our common logarithm of 10. So what we're going to have to do is to get this exponentiated on both sides, we're going to use a base 10. So we take 10 logarithm of 3x will equal 10 to the 9/2 power. That gives us 3x on the left-hand side, and we've got 10 raised to the 9/2 power. And to get x by itself, of course, well, multiply by 1/3. And we're going to find that x is equal to 1/3 times the quantity 10 to the 9/2 power. And that would be fine as an exact value solution. Of course, we might say, okay, square root of 10 raised to the 9th power or something like that. But I think we're good with this kind of answer.